welcome. Thank you so much for joining us today in our second session of our CATIA University training sessions. So today's topic is reverse engineering. The webinar will be recorded and you will find it in your email afterwards as on demand in case you want to revisit any point. We will have a Q&A session in the end, so if you come across any questions during the presentation, don't hesitate to ask and our experts will be happy to answer. I'd like to start with a brief introduction of our Director of CATIA IBU at Bias 3D, Susan Crowden, a dynamic professional with over 20 years of proven sales management experience, business development, and marketing experience in CAD, CAM, CAI, and PLM. Susan has also experience with new technologies such as social mobility, analytics and collaboration, enterprise digital transformation, Internet of Things, manufacturing and product development, and wide expertise in the Dassault system solutions we provide, just like CATIA, Enovia, Simulia, and 3DVIA. We also have our speaker here, Glenn Larson, our Senior CATIA NC Manufacturing Applications Engineer in Bias 3D. Prior to joining Bias, Glenn spent the last 12 years in the aerospace and automotive industry, specializing in engineering and design of parts for the military, NASA, and automotive suppliers. He started out in the aerospace field working in product engineering and eventually became head of engineering of a large defense supplier for the Florida Panhandle. Glenn holds an ASC Master Tech certification in the automotive industry, where he spent his early years rebuilding transmissions. And some of his more important skills include CATIA design, manufacturing assembly and machine programming, CMM programming, VBA, and database development. And finally, last but not least, we have Chuck Giarratana and Daniel Cini, CATIA experts from Dassault Systems that can help us solve whatever questions you may have. So we can get started with our presentation. So Susan, would you like to take over?
Thank you, Kenya. And thank you everyone for joining today for our second installment of CATIA University. Our goal with these classes is to help you understand how you can maximize your SOLIDWORKS by doing some more advanced types of applications with the CATIA product line. Next slide, please. Oh, wait. So the first couple of things that we're going to talk about, we're going to demonstrate how to use CATIA to add GD&T to your SOLIDWORKS project to create manufacturing definition. Next slide. Then we're going to go over how to use reverse engineering to create functional parts from scan data. Next slide. And finally, we'll cover using reverse engineering to validate your first article inspection. Next slide. But first, the good stuff. Yes, we have graduation gifts. We're expecting everybody to graduate with flying colors. What we're doing is for each class that we have, this is the second class, at the end of our session, we'll give away a $50 gift card, Visa gift card, to one lucky attendee. Obviously, you must be present at the end to win. And then for anyone who participates in all the classes, which are going from 7/14 of 21 through 4/6 of 2022, you'll be entered to win a drawing of either a Space Mouse or an iPad, your choice. And we're going to pick 5 lucky winners at the end of all the classes next spring. Next slide. But first, a little bit about who we are at Bias 3D. We are a Dassault Systems Platinum Partner. We're a Dassault Systems Education Partner. We work in multiple industries, oil and gas, petrochemical and process, nuclear, aerospace, so on and so forth. Our team consists of 100 employees with many PhDs and MSc techs in design, manufacturing, and structural mechanics. We also provide engineering and PLM consultancy, and we have a global presence with Nexus in Canada, US, Mexico, India, and we've recently opened an office in Turkey. Next slide, please. So, and who is Dassault Systems? For those of you on the call who may not be familiar with Dassault Systems, they're the world's leading developer of CAD, CAM, and CAE products. They have a product family of more than 120 interrelated software products serving 11 industries, such as transportation, aerospace, marine and offshore, industrial equipment, etc. They enable implementation of design, analysis, manufacturing, and post-production support systems. They have 22,000 people working within the organization. When I first started working with Dassault Systems, they had 3,000 passionate people, but now they've grown to 22,000. They have 12,600 worldwide partners, of which we are one of them, and more than 290,000 enterprise customers for about $5.4 billion in sales annually. So not a small organization. Next slide, please. So our value at Vias 3D is to provide through the application of digital technology, enabling manufacturing and engineering organizations to become better at connected collaboration, process discipline, digital product experience, using digital transformation through the 3D experience platform technology. Next slide, please. So with that, I'm going to turn it over to Glenn Larson. Glenn, take it away.
Thank you, Susan, and welcome everybody, and good afternoon to our second installment of the CATIA University. Today I'm going to do 3 segments, and those 3 segments are going to be, the first segment is I'm going to show you how to use SOLIDWORKS models on the 3D Experience platform. And the second segment, I'm going to show you how to create a model from a point cloud. And the third segment, I'm going to show you how to, for first article inspections, how to do overlays from the reverse engineering. So we'll start out with the first thing that we're going to do is, if you're not familiar with the 3D Experience platform, we have connectors that we can connect not only SOLIDWORKS, I'm going to use SOLIDWORKS as the example today, but we can also use AutoCAD Inventor, we can use NX, and all of these models can come in and be used in the platform as assemblies for anything from simulation to any other applications that you might use a model for. So we're going to start out with showing you some functional tolerancing and annotations. I'm not sure how many of you are familiar with this, but this is really the new way of creating pure model-based definition. It's been around, I say new, it's actually been around for about maybe 15 years or so, but or better. But you see it more and more today. So the workflow is going to be this. We're going to start out, I'm going to open up SOLIDWORKS, and I'm going to create a model where I'll have a model created ready. I'm going to make an edit to it. And then I'm going to upload it to the 3D Experience platform, and I'm going to show you how that works. And what it does is it makes an exact copy for you to work with. And then we're going to take that copy and we're going to annotate it. I'm then going to go back to SOLIDWORKS. I'm going to edit one of the dimensions and show you when we go back to the 3D Experience platform and open up the part that it will be updated. So I'll go ahead and start this video. So here we have a part, and I'm just going to take an edit. You can see we're in SOLIDWORKS, and we have the 3D Experience platform connector. And if you look at the part, it's just a basic part with some holes in it. Nothing crazy. So we'll make an edit to the inside of the hole here, just to show you that it's a SOLIDWORKS part, not just a BREP solid. And we can make edits to this, any kind of edits. And we're going to upload it to the 3D Experience platform right from SOLIDWORKS. So you save with options, and the reason you save with options is because you want to pick the button that says convert. And it's not going to actually convert the file. What it's going to do is it's going to make an exact copy that you can use on the 3D Experience platform. Okay, so it loads really quick. I've got nice fast speed, and so everything loads fast for me. It's the green check indicates it's in there already and ready to use, so it's pretty fast. So here we're just going to go ahead and search for it. I'm going to use my content because this is going to bring all the content up that I've used, and the filter I'm going to pick is the most recent. And you can see there's actually 2 copies of it. I have 3 because I've already done this, and so you can see that there's an assembly already. But we'll go ahead and we'll open the exact copy. And when you look at the exact copy, you can see there's a little red minus sign on it. And that means this isn't editable. You can't really edit this in here. It's a BREF solid, and the only place you can edit this is in SOLIDWORKS. So I'm just going to change the view so we can annotate it a little easier. And again, yeah, I've got a little note here that says you can't, edit it. And so I'm going to open up a new product because everything we do in products. And I'm going to put that BREF solid in the product. And you can name it and name the reference on that. And then I'm going to go and I'm going to insert a part. And this part is, I'm going to name my annotation file or my functional tolerance and annotations were GD&T. However you want to use that term. We're going to lock it down. Now we're going to go ahead and we're going to bring this file in. Now you can do this 3 ways. You can drag and drop it. You can copy it and paste it, or you can just right click and insert. All of those features work. Again, you want to lock this down as well, or constrain it however you will. And so now we're ready to go ahead and start creating some annotations. Here I'm just going to put some dimensions on it, and I'm going to start out with, putting a view in there or a surface. You let the system know what plane you're gonna have these show up on for your view. You can see it creates an annotation set. And then we'll just place some dimensions. And so dimensions are simply as clicking on the surface. It's not that complicated. It's like anything. If you were drafting, the complexity of your drafting depends on your tolerance scheme and how you want them to manufacture it. I'm just putting some simple dimensions on here. Again, just like any dimensions in the properties, you can change the basically what type of value you're going to have, or in this case, I'm going to put it as a standard value and have 2 decimal places. We'll put a couple other things on there. We'll add a datum. And this reading experience is really intuitive. It's super simple to just click on things. Contextual menus will come up. If you just click on a surface, it'll let you know what you can and can't do. And if you just click on something, you can change it. There's no special menus to go through. Super simple. Put one more dimension on there. And again, you could use GD&T on this in a way that made a lot of sense. Put some true positioning on your holes, annotate any datum you want to. You'll see later on that I use a surface profile. So now we've got a dimension in both directions. Okay, so we'll save this, and then we're going to go ahead and close it. And we're going to go back to SOLIDWORKS. And so if you want to use this part, the only thing you have to do is basically reserve it. So you reserve it, you change your dimension here. Again, you're editing the original part. We're going to change that so the hole's a lot smaller. There we go. Bigger in the other direction. Okay, so now we've changed the shape of the hole, and all we have to do is do a save with options again. Really simple. We check the convert button, which creates another exact copy. And we don't have to do anything. When we get back to the 3D Experience platform, you're going to see that we don't really have to do anything to update this. When we open it, it's there. It's just set up that way. So, and what I would add to this is, so we're showing you this just to add some GD&T to a model. But if you wanted to, let's suppose you had this in a simulation or in an assembly. And in the 3D experience, you can have an assembly. It could be a CATIA assembly with SOLIDWORKS parts in it. It could be a SOLIDWORKS assembly with CATIA parts in it. It really doesn't matter. And you can actually simulate that on the platform and do simulations. Or, if you wanted to do, just about any of the functions in the applications that just use models. So if you're doing factory flow simulation, or you're building M-bombs, or any of those things, that can be done. So that is SOLIDWORKS to the platform. So the next segment that we're going to talk about, and this is something I use a lot. I love the reverse engineering and the 3D experience. You just can't even believe the different things that you can do with this. I'm just going to show you a couple, but you can let your imagination run away with you. Here, if you're having difficulty replacing, and we've seen this in aircraft parts, you would have somebody go in and you'd have somebody scan the surface and then use the print to create the part, and then you'd have the surface. And you can line that up that way. Or in this case, this was a fitness for service set of scan points. So somebody scanned a big tank, and then, I created a model from it using the print as well. So it matched print data, but you get the real surface. So what we do is we bring the scan points in, we create a mesh on it, we create a surface, we trim that surface and put some features in there, and then turn it into a solid model. And then we can even do a deviation analysis from the original scan to ensure that the model that we're looking at actually represents the scan. And if you've never seen scan data, today's scan data is super detailed. It can come in with colors and everything else. So you can't use all of that data to build a model. You have to definitely filter it down. But the thing is that you can actually see welds, you can see heat deformation, you can see all sorts of things with the scan. And it's kind of really important when you get into a deviation analysis to look at, let's suppose you had a welded structure and you see it's, all the way up, it's buckled. Well, now you can do an analysis against that. So I'm just going to, without further ado, show you the video. So we're going to create this from a point cloud. And I'm going to start out using, we have 3 applications. I'm going to use digital shape preparation to start. We have digital shape sculpting and digital shape to surface that we will use as well. And these are great applications. They work with STLs, they work with, and I'll show you all the file types. You can use an Excel file with points on it and create your own points and do it. A cell file is limited, so you don't have enough room for a really big model, but you could turn it into an ASC file pretty easy, or use several Excel files. So here you can see that we bring in digital data. I created a geometrical set to bring it in, and I'm going to bring an ASC file. They do come, and you just check the check mark. And then here you can scale it, because a lot of times if it's coming from someplace, it might not be the right scale. But look at all the different formats you can put it in. And so they're all available. Almost all forms of scanners will output the scan data that will go into the 3D experience. So if you look at that, you can actually see the heat deformation in some areas of where this thing's buckled and where they welded it. So I'm going to trim out some erroneous points here because you can do that. Remember, when people scan, anything they reflect off of or hit is going to come back as a laser scan, so you can trim those points out. Then what I'm going to do is I'm going to filter these points down because I can't really lay a mesh on it. I mean, I can, but I'm not going to be able to create a surface from it because it's going to have every little flaw in the tank. Even chipping off paint will show up. So now I have to tell you, I'm not going to stop the video there real quick. You have to, just to back it up a little bit, when you come up with this filtering method, there are several different types of filtering methods. For the size of the model and the weight of the points, each time is something that it's not like just a standard thing there's a standard number. You're going to have to play with this to get this right. Too many points makes a really sloppy surface. And the right amount of points, you'll get a nice tangent surface. So I guess I kind of went too far here. Let me bring it back out to where we are. Out to creating a mesh. So you put a mesh on that points, and you can see the mesh really shows the deformation of this tank. So in this case, I'm going to create a model from it. So I'm going to trim the extra added surfaces because they always scan above the surfaces. So that's why it gets a little funny at the top. So now we simply go into the surface reconstruction app. And we take that mesh and we pick on the surface reconstruction. Again, I'm going to use the default setting here, but again, there's a lot of settings for you to use. So I've got my model created. I'm going to put it in a geoset, and I separate these so I can always go back. I put my points in one geometrical set and my other solids in another, and surfaces. So see those contextual menus? You can just pull them up and down. You can just grab a plane and drag it. That's the beauty of the 3D experience. Makes modeling so much faster. So I've got this one trimmed out. I'm going to put a bottom on it. I just extract the edge. And I put some planes in. Again, see the contextual menus? That works in every application on the platform. And some applications have a lot of contextual menu ability. Sheet metal is one of those, and of course surfacing. There are several apps in the 3D experience for surfacing. Depending on what you're doing and what type of work you're doing, you need to look into it and see. So here I'm just gonna create it like a duck box and trim it out. And this is done in minutes. I know that the video is edited, but the truth is that this is literally done in minutes if you have the scaling right. So again, each time you start on a project, but let's say somebody gave you 20 scans, they're going to all have the same kind of weight. Once you come up with that data, it's quick. Again, we're just going to put some fillets on here, and you see the contextual menus pop up again, like they do in everything. Best part about the 3D experience. Once you use this enough and you see how it speeds your modeling up, watch this, I can just change the size of that by just pulling and dragging. Or if you click on that, you can actually type in the number 2. So, and that's it for that video. I didn't actually create the solid in that one. But to create a solid, you just stick in the surface. So I want to get to probably what I feel is the most important part of this today. And, we may get more questions on, is the reverse engineering for first article inspection. I think anybody that's done any kind of manufacturing has felt the pain of this. You build a part, you machine a part, and you put it in for the first article inspection, and you know, they either okay it or they fail it, and then later you find out it wasn't right. And, you know, this is a problem, and scanning technology is making this way easier. And you can do a lot with this. And I'm actually going to stop this video in the middle because I want to talk about something else you can do with it when I show you. So you can see that, you know, in aerospace particularly, you have a lot of, you know, odd shaped parts that are model-based definition with a profile tolerance. And to get it right, you know, if you have a good scanning technology and good scanning techniques, you can see flaws and deviations immediately. And we'll have an example in the video. What I'm going to do in this particular video is we have a shape, let's see, a stamp sheet metal part, and it's got a profile tolerance on it. And I have some target datums of where they're going to set that on some stands, you know, on their scanning machine. And so we have a datum. And one of the things I'm going to say is really important is how you set your datum up. Now you can move things around in here and scale them very easily, but it's always best if you can bring the part in the same datum. So we'll start out here with this one. We've got a part, and I'm just going to show you the different datums we have. A is an edge, B is the center line, and C is the datum target. And so we have a profile tolerance with some maximum material condition, right? And we're just going to go ahead and create a new geometrical set to bring in some digital data. Now here I'm bringing in an STL file, but this file could be, again, anything. It could even be from an Excel spreadsheet of points. So somebody could use a CMM machine and take points, and you can get the same thing. The more points, the better. So what we're going to do now that we have a geometrical set is I'm going to go to the proper application, digital shape preparation. There we are. And what you'll see is we're going to import, you'll see large digital data and digital data. We're going to use digital data. Large digital data would be if you had scanning from a drone and put it in a big server and that you were just referencing it. It's a great way to do big, giant topical solutions if you were scanning an entire platform or something like that, an oil platform. Here we're just using a shape, so we're going to use an STL. So this file was actually generated from simulation. Again, this could be done with spring-back simulation as well. So I'm scaling it 1:1. I have the datums laid out so that this will come straight in. We're going to use STL. And there it is. And you can see I used something dramatically far off for the purposes that you'll be able to actually see it. And you can see where it's off everywhere just by looking at it. But that's not good enough for measurement. So we're going to use a deviation analysis. And there's a lot of other automation and ways you could set this up that we could talk about, but I'm really just kind of going basic here. Now, I'm going to choose spikes, and I'm choosing spikes for a reason, something I wanted to talk about. So we're going to take the original surface, and then we're going to use as the reference, and then we're going to use the part brought in as to measure. So you can see that everything shows up. And the reason I use spikes, you don't have to use spikes, you can just use points, is because if you look at those spikes and the vectors, if you wanted to do a spring-back analysis and make a, you know, like overbend the part, you know, compensate for that spring-back, you can use those spikes and a percentage to redraw the model in the other direction. So this deviation analysis, I have everything showing up here, but you can pare that down. You can only have 2 or 3 numbers. So you can have in or out of tolerance. You can type your tolerance numbers in of what they actually are and look at the deviation from that aspect. This is a great way to check parts. This is a great way to redesign parts and see what's really going on. I know a lot of people are already using CMM machines and have seen data overlaid and things like that, but this is really a way to do it. And you see you've got the GD&T in here, so you can access that as a number and a parameter if you wanted to, and you know, do a parameter study. So that's pretty much what I had for that section. It comes up a little short, and we do have a pretty big question and answer time to go over any questions and answers that you might have. And I guess I'd see if Kenya has any questions that came up.
Yes, thank you. So we do have a couple of questions here. I'm just trying to open this. Okay. So we have a question here that says, can a SOLIDWORKS model be inserted in a CATIA assembly?
Well, the answer to that is yes. So actually, in the 3D experience, you can build 3 types of assemblies that I know of, and I'm sure you can build more. But if you're, let's just talk about the SolidWorks for a minute. If you have SolidWorks and CATIA and the 3D experience, either one of those assemblies can be started. So you can have a SolidWorks assembly with CATIA parts in it and 3D experience parts in it. Or you can have a 3D experience assembly with SolidWorks and CATIA parts in it. So assemblies and like, so you'll see that if you were to take a CATIA assembly that has SolidWorks models in it, when you open it up in CATIA, you can see their SolidWorks models. They say SolidWorks and have the icon right on them. You can't edit them. You'll have to go back to SolidWorks to edit them, but that can be done. And I hope that answers that question.
Yes, it does. Thank you. We have another one that says, I see in 3D experience you use digitalized shape preparation workbench. Is there anything similar in CATIA V5?
Yes, there are actually. Actually, there are the very same applications are in V5. And one of the best things is that as they develop 3D experience applications, they continually to back develop whatever they can into CATIA V5. Although some of these might have been V5 applications before they were different. So all 3 applications, the digital shape preparation, digital shape sculpting, and digital shape to surface are all workbenches in CATIA V5.
Okay, great.
I hope that answers that.
Thank you. Yes. We also have, are there other applications other than GDT application?
Yeah. So when you bring SolidWorks models into the 3D experience platform, it doesn't just have to be, hey, we can annotate these with some GD&T. You can bring it in. Let's say you were doing a kinematic project and you wanted to, let's just use, for example, a CNC machine. If you want to build a CNC machine. So you can take a kinematic model, and some of the models, the original SolidWorks models can be, you know, the vise or whatever it could be, or even the parts that are in motion. So you could use kinematics on there, or you could use, for example, if you were doing a dynamic simulation and you wanted to do an analysis, collision analysis or a stress analysis. All of these things can be done using SolidWorks models. And by the way, not just SolidWorks models, but models from NX or Creo or Inventor, and of course step files and IGES files as well. There's a lot of formats that the 3D experience will accept. And there's probably, I think there's, I'd have to check for 5 or 6 that actually integrate.
Awesome, thank you. This is not quite a question, but a comment. A great large-scale example of how NIAR is using the platform to digitalize the B-1 bomber.
Okay, an example of, can I have that question again?
It's not like a question per se, but yeah, I think it's a great large-scale example of how it's using the platform to digitalize the B-1 bomber.
So I'm not sure on the B-1 bomber itself because I don't have any knowledge on that. But what I will say is that the 3D Experience platform is using, because it can handle large models, they can build big assemblies of an aircraft and do simulations. So it is being used on not only existing, new aircraft design, but existing aircraft design, because there's still models and things, right? So if you had, let's say you had an F-16 and you had a model for it, and that'll you can bring it up onto the 3D Experience platform without converting it. So those are some ways that it might be used. I hope that answers that question. I wasn't real clear that what, and not having knowledge of the B1 program, it's hard to answer.
Okay. We do have a couple more, I think. So if you import a point cloud and there is an area missing, can they be patched?
Yes. Actually, there's some automation on that. So on the 3D Experience platform, we're even on CATIA V5. When you're working with, when you go from, digital, when you apply a mesh, you can tell it to close holes. You can also do that with the surfacing as well. So you could do it manually, or you could use some automation there, because there's some knowledge word back there. If you have a round cylinder and there's a bunch of points missing in an area, you can use the logic of what is there to help create and extrapolate the shape. It works really well. Sometimes it doesn't make the shape exactly how you want it. Again, you have to be good with understanding it, but it's so easy to manipulate. You can trim and adjust points in such a good way, and then of course add. So of course you can always join surfaces. So I hope that answers that question.
It does. Thank you. We have another one that says, when using a scan to check a part width, how do you get it aligned?
That's a really good question. I think so. It's always best, like if you're using a CMM machine or you're using a scanning, is to set the datum up first so that it comes in the same position. And that's
Glenn, this is Danny Alcini. I can also comment on that as well.
Okay.
You can use registration points as well, which allows the software to key off of the geometry. There's about 4 or 5 quite robust methods to do that. So I just wanted to add that in there. Thank you.
Well, no, thank you, Danny. I appreciate it. Yeah, because there are more than one way to do that, but it can definitely be brought in. So, and even scaled. So that's the nice thing, is that you can make sure you're pretty well lined up. Any other questions?
I think we're done. I don't see any more questions being added in the question section.
Well, boy, I want to thank everybody for coming today. I don't know how's our time? How much time do we have left?
Well, we do still have the drawing of the $50 card.
All right, yeah, let me turn this stuff over to Susan then, and I want to thank everybody for coming. Feel free to reach out to me or our team for further information or how-tos. We also have
wait, Glenn, we do have another question.
Okay, good. Oh.
Yeah, great, sorry. How do you smoothen all the waves? That's a recurring problem when I face when I use reverse engineering. I actually clean up using larger triangles and cleaning up geometry. Is there a better way?
Well, yeah, there are better ways. There's some automation tools that'll help you do it. Depending on what surfacing workbench you're using or application you're using, there are some other ways to smooth the surfacing in automation. We have digital shape morphing that has a lot of capability in it. To do that, to manually have to change triangles is a lot of work. And actually, outside of this, if that's a problem that you can bring into us, we can help you with that, and get you the right tools to do it and show you how to do it. Because adjusting the triangles and trying to manually work on a mesh is just not in my opinion, I've never had to do it. So because the tools are there, and never had to do it in this. When I say that, I've had to do it before in other softwares, but you have tools here that will help you. And it depends on how smooth you want it. Sometimes you want the surface to be what it is, right? If you're checking fitness for service, but if you're making a part and you're creating an aircraft part and you want that to be smooth, there's definitely some tools for that. So I hope that answers that.
Awesome, thanks. It actually does. So yeah, I think we are run out of questions. So if Susan, if you want to move on with the $50 card drawing, that'd be great.
Awesome. Next slide, please. So
There it is. Okay.
yeah, leave that up for just a little minute. We've had a lot of good questions, and thank you everyone for actively participating. Here are our contact information. Here's our contact information. So if you want to reach out to us with further questions about these topics, please do so. We're happy to answer the questions, maybe get online with you and do a little example, whatever it takes to help you be successful. Next slide, please. And now there's going to be a lucky winner of the $50 gift card. So flip back to the previous screen if you would, Glenn. I'd like to ask that whoever wins, I'm going to have Kenya draw a name, and whoever wins, please reach out to me there at my email address and let me know that you are the winner, so that I'm obviously going to need some sort of an email address for you so that I can get you the $50 gift card. So Kenya, do you want to draw a winner, please?
Of course. So I have David Ray.
David Ray. David, are you out there? Yes?
Yes.
Okay, so you're the lucky winner of the $50 gift card. Please go ahead and reach out to me so that I understand how I can get this information to you. Next slide, please. So we want to let everybody know that we're gearing up for class 3, and class 3 will be on relational designs, templates, and automation. The date for the next training class is going to be October 19th at this same time, 9 o'clock Eastern Standard Time. Next slide, please.
I think that's it.
Okay, that's the end. So I'd like to thank everybody for attending today, and that's it for today. See you at the next class.
Okay, and thank you, Susan. And I'll chime in on the relationship design and template automation. Really good stuff, can save you a lot of time. And look forward to seeing you there.
Thank you, everyone.
Okay. Awesome, thank you. Congratulations to our winner, and look for the replay in your email soon.
Thanks, Kenya.
Thank you. Have a great day.
Bye-bye.